that's the end of 2005 AL question. Now let's try to do another past paper question, because doing questions more important. The more we do the past paper question, the more we learn. So let's go to another past paper question. So this is 2005. Let's go the next question. This is 2010, 11. Let's go to 2012. 2012. Right. So somebody unmute the mic and read the question. Wait. Somebody unmute the mic and read the question. 2012 fourth structured essay question, which is given from potentiometer, current electricity lesson. Somebody unmute the mic and read it quick.
Figure 1 shows an incomplete diagram of a potentiometer arrangement used for measuring the internal resistance of a cell.
Thank you, dear. Thank you. So we want to find the EMF of this cell. Actually, the cell means everything, dear. The cell means this part. So the cell is able to generate a certain voltage E, and it has a certain potential difference between its positive terminal. This is the positive terminal of the cell, and between the negative terminal. So there is a potential difference between positive and negative terminals, and there is a resistance between positive and negative terminals. The resistance of the chemicals, the resistance between the positive and negative terminals of a battery is said to be the internal resistance of the cell. That's what we are going to find. Okay, dear? So it is said that incomplete diagram is given. Incomplete, here this. See, incomplete diagram is given. So it means we have to complete the diagram. So what are the missing things as you have observed here? Tell me one missing component in the circuit here. Lamai, what is, can you tell me an incomplete, missing component here?
A galvanometer?
Yeah, we need a galvanometer, but if we write only the term name galvanometer, they will not give you marks. What should be the correct answer here? Galvanometer or something with galvanometer?
Center zero galvanometer.
We should use the center zero galvanometer. To which point should we connect the center zero galvanometer here? Name the 2 points. There are 2 terminals of a center zero galvanometer. Where should we connect them? Here, or at the point A and B, or at the point C and D, or in this S? Where should we connect the center zero galvanometer?
C and D.
Yes, center zero galvanometer should be connected to C and D. Only one student knows the answers. Others are, I think they may sleeping. Center zero galvanometer should be connected to C and D. Galvanometer is always connected to the C and D points. So here we should connect the center zero galvanometer. Capital G should be connected here. And what is the thing that should be connected in between A and B? Can you guess here? In our circuits, we have not connected to C and A and B, but here we have to connect something to A and B. So what's the thing that we should connect to A and B? Somebody please tell me here. There will not be a current in the circuit if A and B are not connected. Therefore, to connect A and B, we have to use a switch here. We have to use a switch. There must be a switch. Sometimes they use the term switch, sometimes they use the term key. Switch or a key, same meaning. So A and B should be connected by a switch, then only current flows to the potentiometer wire. The potentiometer wire is this one here. Here, this one. This is the potentiometer wire. Okay? I think you are able to see it. There must be a current flows to the potentiometer wire, then only we are able to do this practical. So what are the missing points? Center zero galvanometer and the switch. Right. Let's go to the questions. Let's go to the questions. Simple A question. In addition to the items, let me reduce the size, then only we are able to see it. Sorry. In addition to the items provided, in addition to the items corresponding to the symbols shown in figure 1, if you are provided with the item shown in figure 2 to perform this experiment, so they have given these 4 items. They have given these 4 items. Which item would you connect in between A and B? What's the thing that we connect in A and B? In A and B, we should connect a switch. There are 2 switches. Which switch is more suitable? Switch number 3 or item
Number
number
3,
4?
sir.
3. Do you know the name of this switch here? How to operate this switch here? A is connected to this node. B is connected to this node. How to switch this on, dear? How to switch this on? You have to press this knob by using your finger. Can you see? Once this knob is pressed downward by using your finger, this metal piece will contact in this metal piece. Then only the switch is completed. But if you slightly remove the finger, what will happen? The circuit will be open. So it means you have to always press this point downward, press this knob downward to operate the circuit. Is it easy or difficult here? Is it easy or difficult? Somebody? Lamai? ඇයි බං ඉතින් මේක ඇඟිල්ල ඔබන් ඉන්න එක අමාරුයි කියලා කියන තරම්වත් උඹලට කටක් කැරෙන්නේ නැද්ද? එච්චරටම නිදිමතයිද? මේක ඔබාගෙන ඉන්න එක අමාරුද ලේසි වැඩක්ද?
It's difficult, sir.
It's difficult. අට හොල්ලන එක කොච්චර අමාරු නම් මේක අත හොල්ලන් ඔබන් ඉන්න එක කොච්චර අමාරු වේද? So therefore this switch is not suitable. Right, so we should select switch item 4. How to use this switch item 4 here? Can you see the middle wire, middle thing? It's a metal nail. If you take it out, if you take this middle one out, the circuit will be disconnected. Switch is open. This is point B is connected to here. A is connected to here. If you remove this middle plug, the switch will be open. Once this plug is placed here, switch is completed and no need to apply any force to keep the switch on. This kind of a switch, the switch shown in item 3 is said to be a tap switch. What's it called here? What is it called? Somebody please talk to me.
Tap switch.
It's called a tap switch. So difficulty with the tap switch is you have to always push it downward to keep it. And the amount of current flows to a closed tap switch depends on the pressure applied on it. The pressure applied on this switch by the finger determines the resistance of the switch and the current flows through it. So if you use a tap switch, we will not be able to obtain a constant current. In potentiometer circuits, the current in the potentiometer wire should be a constant one. Right, so what is the answer for Roman number 1? Simple A, Roman number 1. You want to say item. Answer for simple A Roman, wait, I'll show you. Answer for simple A Roman number 1 should be item number 3. That's how you want to give the answer. Item, not 3, item 4. The fourth item should be used in between A and B. Right in here, this is the answer for simple A Roman number 1. So start 2012 AL question. 2012 fourth structured essay question, which is given from current elective lesson. Simple A Roman number 1 is item number 4. Simple A Roman number 4 is item number 2012 fourth structured essay question. Answer for simple A Roman number 1 is item number 4. Then Roman number 2, which item you would connect in between C and D? In between C and D, we should connect the center zero galvanometer. Here we should connect the center zero galvanometer. Right. So there are 2 galvanometers. Which galvanometer is the center zero galvanometer? Which one is the center zero galvanometer? Somebody please tell me dear. Lamai?
First one.
First one, yes dear, why not? Can't you see this zero? Like if you want, I'll increase the size, you see? Zero is here. Zero is at the middle, pointer is here. Center zero galvanometer. So item number 1 should be used here. So what's the answer for simple A? Simple A Roman number 2, item number 1. Item, you can write like this. So this is the answer. Item 1 shows the center zero galvanometer. So we should use a center zero galvanometer in between C and D. Therefore, item number 1 should be used. We should not use a tab key in between A and B. We should get permanent key, something like shown in item 4. So answer for Roman number 1, item 4. Answer for Roman number 2, item 1. Simple B question. Somebody unmute the mic and read simple B question. Start.
This experiment, after the apparatus is set up properly, 2 balance lengths must be taken. What are they?
Thank you, dear. Thank you very much. So after setting up this instrument, we should obtain 2 balance lengths. The first balance length is obtained by keeping this switch on. The switch is kept on. Switch S is kept on and we obtain the balance length. Can you understand? A center zero galvanometer is connected here. Center zero galvanometer is connected here. Right? So galvanometer is connected here. Like this. Right? Galvanometer is connected in between C and D. Switch S is kept open. Then we obtain the balance length. Once this balance length is obtained, listen dear, then this part, as switch S is open, no current flows in this branch. Can you identify that point here? Right? No current flows in this branch when switch S is kept open. Therefore, it is something like that, no circuit. It's something like that, no circuit in the in this circuit. It's something like that, this circuit is not there. Like this part is not there. Right, this part is not there. So then potential difference, look at board carefully. then the potential difference between this point, potential difference between this point and this point should be equal because no current in this branch. Similarly, potential difference between this point and this point should be the same. So it means if the potential difference across the wire, we should measure this length. We measure this length. We measure this balance length. Right? Balance length L1 is measured, and that is equal if this balance length is KL. If this balance length is L, if this balance length is L, then the potential difference across the wire is KL volt. KL volt. Got it? So this KL volt is equal to the EMF of the battery. Can you understand here? This KL voltage between these straight two boxes is equal to the EMF of the battery. So from this, that's the first balance length. So first balance length is obtained by keeping the switch S open. Right. So they ask us there are two balance lengths should be obtained. So what are the two balance lengths? So please write. Please write. Simple B equation. Please write. Balance length when the switch S is kept open. So please don't be confused with the S that we have written. I'm talking about this switch S, this one. I'm talking about this switch. Okay, right. Roman number. The first balance length is the balance length when the switch S is kept open. Number two, the balance length when the switch S is kept closed. I have explained this practical last week, right? You must remember the practical. The second balance length is when the switch S is closed. So what will happen when the switch S is closed here? Then there will be a current in this branch. Do you remember? There will be a current in this branch. Then we have applied Kirchhoff law to this branch. We have applied Kirchhoff law to this branch. But no current in this branch and no current in this branch. As usual. There will be a current only in this branch. Do you remember that I have explained this theory part last week? So we should obtain two balance length. The first balance length when the switch kept when switch S, this switch, when the switch S is kept open. The second balance length is when the switch S is closed. So we have answered both simple A and B equations. Now let's go to simple C equation. Simple C equation. Can somebody unmute the mic and read simple C equation here? Somebody in the class?
If the balance lengths taken by a student were 90 centimeter and 80 centimeter, the value of capital R was 5 ohms during these measurements.
Right, they ask us, thank you dear, they ask us to find simple R. Calculate the simple R resistance. Calculate simple R. Simple R is the resistance, internal resistance of the battery. So it is asked us to calculate the simple R resistance of the battery. They have given capital R was 5 ohms during the experiment. So we should find capital R. The two balance lengths 90 centimeter and 80 centimeter. So 90 centimeter is the balance length when the switch S is kept open. Right. So please write for simple C. Please write 90 centimeter is the 90 centimeter is the balance length. Is the balance length when the switch S is kept open. When the switch S is kept open. Right, let me use some letters to explain this here. 90 centimeter is the balance length when the switch S is kept open. Let me mark some points like A and B. AB points are there, so I have used some other points. So let me take this is Y and this as x. So xy is the initial balance length. So distance from x to y is, the distance from x to y is 90 centimeter. Therefore, potential difference between x and y, let me mark it there. So the potential difference between x and y, V xy equals KL, right? Here, this L is, you can mark this as L1, that's good, that's much easier. L1, and L1 is given as 90 centimeter. So this is the story. Clear? Vxy is KL1, L1 90 centimeter when the switch is kept open. Wait. I would like to mark some other points like this. This is CD is there. So let me mark something like F. Right. When no current, look at board. When no current flows through we take all the readings when no current flows in XF branch and YC branch. YC branch. If you want, I can draw you the galvanometer also. If you want, I can draw you the galvanometer also here. Right? So there is a center zero galvanometer is connected here. Right? Capital G. Right. So we take all the readings. When no current flows through FX and CD branches. What's the point here? All the readings are taken when no current flows through XF branch and CY branch. So it's better if you draw this circuit and write the things, but I think we don't have that much of time to write these things. Therefore, the best thing is, the best thing is take a screenshot. Take a screenshot and draw this circuit at home. Keep some space to draw this figure at home. Now take a screenshot. Okay, dear? Lamai? Okay,
Yes,
draw the
sir.
circuit here. You didn't talk to me, it means you want to draw. I'm so sorry. I thought that you didn't like to draw. So you didn't talk to me, it means you like to draw. So please draw it here quick. Draw and mark all the things quickly. Please quickly draw them and tell me once you have finished it. Quick, start. Did you draw the circuit, dear? Did you draw the circuit? Who wants more time to draw it? Right. So I have said that all the readings are taken when no current flows to XF, this XF branch and CY branch. So when no current flows through them, yeah, wait. So then we can write that. Let me write here. Then we can write that the potential difference between X and Y, then VXY should equal to VFD. Sorry, VFC. VXY is given by the equation KL1. VFC is exactly capital E. The potential difference between F and C is capital E. Got it, dear? So this is our first equation. Okay. Complete it, dear. So potential difference. Then Vxy should equal to Vfc. Vfc, the potential difference between F and C is E because no current flows in this branch. You see here the switch S is open. As switch S is open, no current flows in capital R resistor or in this branch. So as no current flows this in FC branch, R resistor cannot generate any potential difference. Therefore, Vfc is equal to the EMF of the battery. No current flows in FC branch because the switch S is open, right? So as no current flows in FC branch, this simple R resistor cannot generate any voltage. Got it? So this is our equation number 1. This is our equation number 1. And L1 is given as 90 centimeter. We can use it later. Okay, dear? Is everything clear for you, Lamai?
Yes, sir.
Yeah. Then let's go to the next part. I'll erase all the things. If you want, please take a screenshot. I'm going to erase everything that I have written. So we have obtained the first equation. Now I am only interested in equation number 1. I don't have any interest with any of the other things. I have interest only about the equation number 1. Let me keep the equation number 1 somewhere here. Right. Now, okay. Now the switch S is closed. Then what will happen? Right. So now this switch S is closed. Once the switch S is closed, there will be a current in this branch. Please write, start point and write. When the switch S is closed, a current flows in the given battery capital E and the given resistor capital R. When the switch S is closed, a current flows in the given battery capital E and the given resistor capital R. Clear? That current flows even through the internal resistor simple R. That current even flows through the internal resistor simple R. Got it? When the switch S is closed, a current flows through the given cell capital E and the given resistor capital R. Full stop. That current even flows through the even through the internal resistor symbol R. Can somebody read that sentence here? Somebody please read that sentence. Someone in the class.
When the switch S is closed, the current flows in the given battery E and given resistor capital R. That current even flows through the internal resistor simple R.
Thank you, dear. Thank you, dear. So please write. Let us apply Kirchhoff's second law. Let us apply Kirchhoff's second law. Let us apply Kirchhoff's second law to the closed loop. To the closed loop. F capital F, capital G, capital F, capital G, capital H, capital H, capital H. Let me use the letter J, this branch. So let us apply Kirchhoff law to the closed loop. Let me write it somewhere here. Let us apply Kirchhoff second law to the closed loop. F, G, H, J, F. Can you see it here? I have written separately. Can you see it here? Lamai? Let us apply Kirchhoff second law to the closed loop. F, G, H, F. So if we apply Kirchhoff's second law to that loop, the only EMF source in that loop is capital E, and there are two resistors, I into capital R and I into simple R. Here, I can be taken out from a bracket because I is common. As I is common for both, I can be taken R out. I can be taken out from a bracket. So the remaining terms will be simple R, capital R plus simple R. Got it here? So let me mark this as my second equation. Right. But now you should, let's take 10 more minutes to complete this. You should draw this circuit and write this equation. You should draw this circuit when the switch S is closed. You see, I have used some letters. Even I have used some letters. Therefore, you have to draw this circuit. Draw this circuit, and now this is not L1. Wait. Now this is not L1. This is L2. This is L2. Now this is not 90 centimeter. It is 80 centimeter, as I remember. Now this is not KXY. This is KXZ, because this point is now Z. So I have changed the circuit. So please draw this circuit. Then only you can understand. Right? Earlier you rejected to get a screenshot and draw, though now you draw it quick. Please quickly draw this. This is the circuit when the switch S is closed. Draw it quick there. Start. Please tell me once you have drawn the circuit here. Please tell me once you have completely drawn it. At what time do we take the readings here? Wait. Where is the drawing section? Yeah. So at what time we take the readings here? As usual, we take the readings when the galvanometer reading is 0. So I just want this equation. I want only the equations. Right. So I just want 1 and 2 equations. I kept them somewhere here separately. Right. Now I'm going to write that. I'll use a different color, then it can be seen clearly. Right. So I have kept 1 and 2 equations separately. Right. Now we should say that, as usual, we should say the balanced length. The balanced length. Please write with me. The balanced length L2 is measured. L2 is measured when the galvanometer reading is 0. Right? Okay, dear. The balance balance length L2 is measured when the galvanometer reading is 0. Right? So at that time we can tell you that at that time Vxz equals to Vfj. Got it? Vxz is always as usual. K here L2 equals Vfj. Here Vfj, the potential difference between F and J. There are two methods to obtain this potential difference. E volt is into this direction. E volt is into the direction of Jf. And the potential difference created across this simple R resistor is into the opposite direction. That is that I into R, I into simple R potential difference is into the opposite direction. May I show you here? The potential according to Ohm's law, when there is a current, when current flows to a resistor, a potential difference is formed across the resistor. That potential difference is given by the equation V equals IR. So this potential difference is given by the equation V equals current is capital I, resistance is simple R. Resistance is simple R. And E voltage is into the opposite direction. Can you understand that? This is E. So this is one of the method to obtain. So potential difference between F and J is equal to E voltage from J to F direction. IR voltage is from F to J direction. Therefore, the resultant potential difference is E minus I into R. If you are not clear, if you are not okay with it, please ask. Right, so that's what I have written. The balance length L2 is measured when the galvanometer reading is 0. At that time, Vxz is equal Vfj. Vxz is KL2, Vfj is E minus IR. E minus IR. Got it? There are many ways to simplify this. What can I do? So let me mark this as my third equation. Please write here. Third equation. Right, we know that L1 is 90 centimeter, L2 is 80 centimeter, and we have three expressions. So at home, solve this 1, 2, 3 equations and find capital E and simple R. Please find both capital E and simple R and send me your answers to my WhatsApp. So I think that's enough for today. If you are reading all these things, you can leave the class. Okay. Solve these three equations 1, 2, 3 at home. Find your answers and send me your answers to my WhatsApp. Right. Good night. See you. Bye. So these are the three equations. The equation 1 tells us KL1 equals E. Equation 2, E equals I times R plus R, capital R plus simple R. Third equation, KL2 equals E minus I into simple R. So we have to use the three equations and we have to find simple R. So if you consider 1 and 2 equations, right? Let me write here. From 1 and 2 equations. See, from 1 and 2 equations, we can obtain this result. From 1 and 2 equations, we can obtain this result. This, from 1 and 2 equations. Yeah, if you want, we can use third equation also. From 1 and 2 equations, right? Let me write the second equation first. The second equation tells us capital E equals capital I times capital R plus simple R. But according to the first equation, you see here, according to the first equation, capital E equal KL1. Capital E equals KL1 according to the first equation. Therefore, in the place of capital E, I can write KL1 equals capital I times capital R plus simple R. Right? So let me mark this as my equation simple A, or you can say capital A, anything. I would like to use simple A. So similarly, I'm going to do the same process. Similarly, I'm going to use the third equation. See, from equation 3, right? Third equation tells us, if you check the third equation carefully, right? It tells us KL2 equals capital E minus I times simple R. Am I right? Right. So I'm not going to do anything to KL2. I'll keep KL2 as it is. But in the place of E, capital E, I can use the first equation. You see, according to the first equation, E equals KL1. Minus, this is I times R, not change. I times R, simple R, not change. Can you identify this, dear? Okay, can you identify this? Right. I'm going to do something like this. I'll take this minus I times R to this side, so it will be positive I times R. Minus IR comes to this side, positive IR. And nothing will happen to KL1 plus KL2. Can you see this? This plus KL2 goes to the other side as minus KL2. Plus KL2 goes to the other side as minus KL2. Right? So let me mark this as simple B equation. Now I have two equations saying simple A and simple B. So whether you have obtained the answers or not, you must write my answers separately. So start from this, from 1 and 2 equations, obtain simple A equation. Then use third equation and try to obtain simple B equation. Please write them all here, quick. Please write them all. Write them all and tell me once you have completed. I don't care whether you have obtained the answer or not. Now you must write my answers separately. Start. Right, now what should we do to solve this problem equations dear? What's the easiest way to simply solve these equations? Lamai? Can you hear me? Can you hear me, Lamai? Okay, you can't hear me, right?
No, sir, we can hear you.
Okay, thank you. Right, the easiest method to simplify this is I'll divide, can do anything, which is the easiest one. I'll divide simple B equation by simple A equation. Right. Simple B equation, I have to change the sides. KL1 should be divided by K terms side. I'll take K terms to one side. KL1 minus KL2. And I'll take I terms together. So equation B, B by A. Sorry, I have changed A by B. A by B. Right. A is KL1, B is KL1 minus KL2. I terms should be taken together. I into capital R plus simple R divided by I times simple R. So you should understand this here. It must be very much clear. See, it's KL1 divided by K term can be taken out from a bracket in the denominator side. L1 minus L2 will be there. Term K can be taken out. So this is equal. This is equal. You see, the term I can be cancelled out this side. This term I and this term I can be cancelled out. So remaining terms will be R plus simple R divided by simple R, because I terms are cancelled out. Similarly, here you see this, that K terms are cancelled out. Similarly, K terms are cancelled out. So remaining terms will be L1 divided by L1, sorry, L1 divided by L1 minus L2, because K terms are cancelled out. K terms are cancelled out. Right? Equals here, they have given us the value of capital R actually. They have given the value of capital R as 5. The only unknown term is simple R. The only unknown term is simple R. Right? Divided by simple R. Right. They have given, it can be, if you want, you can simplify it like this. You can take simple R term to this side by cross multiplication, and denominator L1 minus L2 can be taken to the other side by cross multiplication. L1 divided by L1 minus L2. Denominator L1 minus L2 can be taken to the other side, and similarly denominator simple R can be taken to this side. So it will be something like this. If you interchange the terms, it will be L1 into denominator simple R come to this side as multiplying simple R, right? Equals similarly L1 minus L2 denominator goes to the other side as L2 minus L1 minus L2 into the denominator side, and it will be the product, right? So division becomes product when it goes to the other side. So this will be 5 plus simple r. So you should identify that this is a structure, this equation. So there will not be any space like this to write all the steps and do the simplification. You must be able to do the simplification at once without writing all the steps. But here I am teaching. So I'll explain all the steps for you. L1 is given as 90 centimeter. I'll write you the units, then you can easily identify. Into simple r. I am not going to convert centimeter into meters. I'm not going to convert centimeter into meters. So similarly, L1 is 90 centimeter minus L2 is 80 centimeter into, let me increase the size, into 5 is capital R plus simple r. That's the thing we want to find, right? So next step, you should identify this. Centimeter terms will be cancelled out if you look at it carefully, right? 90 centimeter into simple r equals 90 minus 80, 10 centimeter. 90 minus 80, 10 centimeter into 5 plus simple r. So now you should understand the centimeter term at this side and centimeter at this term cancelled out, and similarly this 0 and this 0 cancelled out. Can you identify them here properly? Centimeter and the 0, centimeter and this 0 cancelled out. Here we have 90. Here we have 90. Not 90, 9r. The other side we will have 5 plus simple r. 5 plus simple r. So let me take simple r term to the other side. So it will be 9r plus simple r come to this side as minus simple r equals, only 5 will be there. Only 5 will be there. Got it? So let me move this a little bit up, right? So then nine r minus r, that is 8r. 8r equals 5. If you take 8 to the other side, then you can easily subject simple r. In simple r equals, I have written all the steps for you, 5 divided by 8. So what is the answer? What's the answer? Lamai? Simple r equals 5 divided by 8, 0. Point. 50 divided by 8. 5 times 8 times 5, 40. 8. Can you simplify this there without my help? You would try. Check all the simplification steps. If you divide this, you will get the answer as 0.625. Do not forget write the unit ohm. Do not forget write the unit ohm. Who got this answer at home, dear? Who got this answer at home without my help? Anybody in the class? Lamai, who got this answer? Because this was given as a homework, that's why I'm asking. Right, let's go to the next part of the question. Let's go to the next question. I think you have written everything, but if you want, please take a screenshot. Let's go to the next part of the question. Right, now we should answer simple B completely answered, simple C completed. Now we should answer for simple D question. Right, now somebody unmute the mic and read simple D, simple D and Roman number 1. Start. Read somebody simple D.
For maximum accuracy, the potentiometer must be adjusted so as to give largest possible values for the balance lengths. Problem number 1, which of the two balance lengths mentioned in B above must be used for this adjustment? Give reasons.
Okay, thank you, dear. So unfortunately, we don't have boys in the class. That's why you girls always read the questions. But thank you very much. For the maximum accuracy, the potentiometer must be adjusted so as to give largest possible values for the balance lengths. Right, which two of the balance length mentioned B above must be used for this adjustment? So for the maximum accuracy, right, L1, L2 should be largest. Clear? So which length should be used for this arrangement here? It means we are able to do something like this. Let me show you the circuit right here. We can adjust this R1. Can you see this R1? We change this R1. Let's say for example, let me show you something. For A and B should be connected, and C and D, we should connect a center zero galvanometer in between C and D. In between C and D. Now we are going to obtain the balance length L1, not L2, because L1 is we are going to obtain the balance length L2, not L1. We are going to obtain L2. So to obtain L2, we have to close this switch S also. We close the switch S, and other switch, the second switch, if you want, you can name it as S2. The switch S2 kept open. Can you understand here? Switch S is closed and switch S2 kept open. Right. Then we place a sliding key on many different places of the potentiometer wire. Then we can identify a region which gives zero deflection in the galvanometer. So when the switch S2 is kept open, wherever you place a sliding key in this red color region, the galvanometer reading is 0. The galvanometer reading is 0. After that, switch S2 also closed. Switch S2 also closed. Then we place the sliding key only within the approximate balance region, no, only within this circle, only within this part. Then only a single point gives you the zero deflection. Then only a single point will give you the zero deflection, right? So let me take that point. Here earlier it was 80 centimeters. Now we have changed R1. We have changed R1. So then let's say the new balance length. Let me change the approximate balance region slightly. So let's say approximate balance region is somewhere here, right? Right, now only one point will give us the zero deflection. So let me take that point to be here, like this, right? And let's measure the new balance length. Let's measure the new balance length L2. Earlier it was 80. So we have adjusted R1. Now the new balance length is, new balance length L2 is, for example, let's say 96 centimeter. So our target, our main target, that's the point that you did not understand earlier. Our main target is to increase both L1 and L2. To increase both L1 and L2, we have to increase R1. When R1 is increased, resistance is increased, current is decreased. When current is decreased, to obtain a certain potential difference, we have to obtain a larger balance length. If you have a doubt about it, I'll explain it separately. Right. Now L2 is 96. Earlier L2 was 80. Now L2 is 96. Both L1 and L2 is are increased. If we repeat this experiment, if we try to find L1 now, that's the problem we faced. We adjusted R1 by using balance length L2. Right? So we have adjusted R1 until the balance length L2 becomes 96 centimeters. Now we will face the real practical difficulty when we are going to find the balance length L1. To obtain balance length L1, S should be kept open, S2 should be kept open, and here this will not be there, right? Now let's repeat the practical. Now, if we try to do this practical again, to obtain the balance length L1 earlier it was 90 centimeters. Now L1 should be larger than 90 centimeters. Earlier L2 was 80, now L2 is 96. Now L1 will be greater than 90 sometimes. Most probably it is possible to have a balance length out from the length of the potentiometer wire. So balance point may be bigger than the length of the potentiometer wire. Therefore, when we are going to do adjustment for the balance length L1 and L2, we should use the larger balance length. We should use the larger balance length L1, right? So in this experiment, we adjust R1 resistor with the largest balance length L1 until it becomes becomes larger than 90, for example 98, 97 7 centimeters, then the balance length L2 will also be increased. It was earlier 80, now it may be 90, 92 centimeter, like that. But if you use the smaller one, the larger one will be bigger than the length of the potentiometer wire. Is it clear, or may I again explain here? If you want me to explain again, please tell me.
Sir, can you explain again?
Yeah, it asks us to increase both L1 and L2. L1, let me type the L1 values, earlier L1 values here. Earlier L1 was 90 centimeter. Earlier L1 was 90 centimeter, right? Now, now by adjusting this R1, right? Let's say I have increased new L1 up to 98 centimeter. I increase L1 up to 98 centimeter, right? I think you are able to see this, right? So once we change R1, both L1, L2, both will be increased. Not only L1, but both L1, L2 increased. Got it? Now we are going to do the practical for L2. When we try to find L2, earlier L2 was 80 centimeter. 80 centimeter. Due to the adjustment of this R1, the new L2 may be, I'm just putting some arbitrary values, 94 centimeter. Now what has happened to both L1 and L2s? Would you please tell me what has happened to both L1 and L2 after the adjustment of R1 here?
They have increased.
They have increased. Both, very good. Both have been increased. That's what asked in the question. The question asks us to increase both L1 and L2 by adjusting R1. It does not say clearly R1, but both R1, both L1 and L2 increased. They ask which balance length should be used for this purpose. To adjust R1, should we use L2 or should we use L1? That's what they have asked. Clear here? They have asked whether we should use L1 for the adjustment of R1 or whether we should use L2 for the adjustment. Now let's say we use L2 for the adjustment. We use L2 for the adjustment. Without using L1, we use L2. Now listen to me carefully. Now I adjust R1 until earlier L2 was 80 until L2 becomes 98 centimeters, something like this, right? We use L2. L2 means this switch is closed, S2 closed. Both switches are closed and obtain this L2, right? Now, if we repeat this practical, now after that we are going to find L1. First we found L2. We have adjusted R1 until L2 increased from 80 centimeter to 98 centimeter. Now we are going to find L1. Earlier L1 was 90 centimeter. So due to the adjustment of R1, L1 will also be increased. So if 80 centimeter value, if 80 centimeter increased up to 98, 90 centimeter may be increased up to, can you guess? If 80 centimeter is increased up to 98 centimeter, the balance length L1 will be increased from 90 to sometimes 110 centimeter, something like that. This is the problem here. Normally, if you check in your school lab, length of a potentiometer wire is about 1 meter. Now this length is has become greater than 1 meter. So will you be able to obtain L1 or not under this condition? Lamai?
No, sir.
No, you cannot obtain. So therefore, to adjust R1, because L1 is now bigger than the length of the potentiometer wire. So to do this adjustment, we must use L1. So we adjust R1 until L1 becomes something like this, 90 to 98. After that, we start adjusting, finding L2. Once we try to find L2, earlier it was 80 centimeter. Now both L1 L2 should be increased. 90 has increased up to 98. So most probably L2 will maybe increase up to 88 or 89, maybe maximum maybe 91 centimeter. Can you understand here? Now both L1 and L2 are larger, and both L1 and L2 are smaller than the length of the potentiometer wire. Got it here? Both L1 and L2 lengths are increased, but both L1 and L2 are smaller than the length of the potentiometer wire, so we are able to do the practical. Got it? So which balance length should be used to do the experiment here, Lamai? Which balance length should be used to adjust R1? L1
L1.
or
L1.
L1.
L1. So that's the answer. So let me show you the question once again. So these things are somewhat, I know these things are somewhat difficult. So you must give maximum concentration. Only very few people are selected, right? So you have to work so hard to achieve your dreams. If you see, even some of the students, they have paid to my class, but I didn't allow them to join now, because paying, and if they pay, they must learn. If they pay and sleep during when I'm teaching, I can't keep them in my class, because I know the pain when students pay, right? I have seen the happiness of the students who pass the exam. At the same time, I have seen the sadness of the student who fail the exam. So it will be very difficult for the students to digest when they fail. Can you understand it? I have seen some students, sometimes you may not believe. So when students fail, right, your loving parents becomes devils. Your loving parents becomes devils. You think your parents, they love you a lot? No. Once you fail, some of the parents, they have sent their children to work in garment factories. Even these days, you see, corona is everywhere. Corona is killing people, but some parents, they have sent their children to garment factories. Now you can't learn, you are an idiot. The only thing, you will be a security guard in a garment factory or cut clothes in garment factory. If you die due to corona, it's your face. You are a useless fellow. Do you want to face the same thing? Or should I be hard, should I be tough for you? As a teacher, what should I do, dear? Should I be tough, or should I blame? Should I hit? If it is possible, even I hit you. To avoid that much of a sadness, what can I do for that kind of things, dear? When a girl or a boy call to me and says, I am working in the garment factory, this is what has happened. Everything in the home is now changed. Now they don't love me much. Now they are considering about my younger brother and sister. Right? They don't pay any fees for me even to do the second shy or third shy. So what can I do? You should know that prevention is better than cure. I can't prevent. I am trying to prevent your damn future, dear. You can't digest it. You can't digest the way your parents change once you fail the exam. Not only the parents, all the other things. Sometimes you may have found some partners, they will also leave you, saying you are an idiot. I can't. How can I marry an idiot? Can I change those things? Right? If I don't blame you, if I'm not being hard, tough for you, some students will definitely pass the exam. I have identified some students who will definitely reach to some district ranks. I know them. I can tell their results also now by looking at them. I'm not talking to them. There are 5-6 students, they will definitely reach to not only district ranks but also island ranks. I'm not talking to those 6 students. I'm talking to the others, because others also pay for me. You don't know the changes that will take place once you fail the exam. So I don't want to hear any more sad stories after the examination. Hereafter I'll be really tough, because when examination is coming closer, you have become worst. I can't understand the changes in you. Whether there is corona or whatever it is, even there is a civil war, we have to sit for the examination. You are an individual person. Whatever happened to the world, you have to live. You have to live. That's the point. Parents cannot be with you forever. There may be some younger brothers and sisters. I think parents are right. They have invested you, they have done everything for you, but you have worked as a real idiot. Right? So I don't want to hear any more sad stories. So next time when I ask a question, you must answer. I'm not talking to those 6 students. I know their results. Forgive me if all those 6 students are also here. Please forgive me. I'm not blaming to you. I know your results. Right. I'm not advising you, because no need to advise to those 6 students. If my future is secured with those 6 students, I just want to take a photo with those 6 students and publish it. Then students will come to my classes. My future is secured, no problem with me. Right? Even I have good number of students in 23 and 22 batches. I don't care. I am 100% okay. Even I can find another job easily, because I have 2-3 degrees. Even I can join to university. I'm talking about you. So please try to understand. Please don't sleep in my classes. Write the notes properly. When I ask you to read a note and answer my questions, you must answer. Right? Okay. Right. So this is the question that we are going to answer. Simple D. For maximum accuracy, the potentiometer must be adjusted so as it gives largest possible values for the balance lengths. So we must do some adjustments to increase both L1 and L2, right? So we should select one balance length, L1 or L2 for this. So which balance length mentioned in simple B must be used for this adjustment? Give the reason, right? So the balance length, please write with me. The largest balance length. The largest balanced length that was obtained by keeping the switch S opened. Switch S opened is used for this adjustment. Right. Now I want to tell you something further. Listen, write the answer. After that, I'll explain this further. Right. So what's the answer? The largest balance length that was obtained by keeping switch S open is used for this adjustment. The largest balance length is used for this adjustment that was obtained by keeping the switch S open. Right. I want to tell you something. You will be sad once you hear this, right? First you write. Right, the most upset thing is, even I was a teacher during 2012 A-level examination took place. The thing here was some student, they have not written this sentence, this part. Oh, wait, I'll draw it again. They have, even some of my students, they have not written this. So as that part was not written, it's not transparent. As they have not written, that was obtained by keeping the switch S open. Examiners, they have not given marks. That's the point. They have written everything. The largest balance length L, the largest balance length is used for this adjustment. But they have not written this. The largest balance length means the balance length that we obtained by keeping the switch S open. By keeping the switch S open. Let me show you the switch S here. Go. Oh, I think I have here. You see this one, this switch, right? The switch with this capital R, the switch with this capital R. So they have not written it. You see the unfortunately, some of the students, they have forgotten to specify this one, this switch. They must specify the largest balance length that was obtained this part by keeping the switch S closed. So they have forgotten to write it, so no marks given. So please don't make that kind of mistakes there. Clear? Do not forget to give complete answers. So what's the complete answer? The largest balance length that was obtained by keeping the switch S open is used for this adjustment. Okay, dear? Is it clear, or may I go to the next question, dear? Is it clear for all, Lamai?
Yes, sir.
Yeah. So if so, let's go to the next question. How did I give you the reason?
No, sir.
Yeah, we must, because they have asked a reason. So let me clear. Okay, right. Right. Which give the reason. What is the reason there? If we use the other balance length, both balance, we may not be able to obtain the both balance lengths. Okay, dear. That's the reason. Which of the two balance lengths mentioned in above must be used for this adjustment? We have said. So please write reason. Reason. If the smaller balance length was used for the adjustment, for the above adjustment, if the smaller balance length is used for the above adjustment, comma, the larger balance length may be larger than the length of the potentiometer wire. The larger balance length may be larger than the length of the potentiometer wire. May be larger than the length of the potentiometer wire. Then it cannot be obtained. Then it cannot be obtained. Then it cannot be obtained. Okay, dear? Can somebody read that answer once again? Somebody in the class?
If the smaller
Again, are you
balance
sleeping?
length, the smaller balance length was used for the above adjustment, the larger balance length may exceed the length of the potentiometer wire. Then it cannot be obtained.
Very good. One more student, please read that point. Right, read that answer once again. One more student in the class.
If the small balance length is used for the above adjustment, a larger balance length may be larger than the potentiometer wire, then it cannot be obtained.
Very good, very good. Thank you. So, right, let's go to the next question. D Roman number 2. With what item do you perform this adjustment? So, what's the item? I have already shown you. Which item should we use for this adjustment here? We want to increase both L1 and L2. So, which item should be used for to increase both L1 and L2?
R2.
R2. R2 or R1? Let me show you the circuit again.
R1 resistor.
Can you
R1,
show the
sir.
diagram again? It's
Which
R1,
one?
right? R1.
Which one dear?
R1.
Again?
R1.
Ah, very good. So we used R1. So students should be conscious there. Then only you can learn and then only you can pass this examination there. Do not suffer after the examination saying that she left me, he left me, he selected university, I am at home. Don't suffer like that saying because I can't do anything. So the answer is R1. Right? So D Roman number 2, answer is R1. Answer is R1. Right. Now somebody unmute the mic and read simple E question. Read simple E question.
If an R value must larger than 5 ohm is used in the circuit when taking measurements under simple B above, would you expect a more accurate or less accurate value for simple R? Give reasons for your answer.
This is the critical question here. Only very few students will be able to answer this question. Right? So if you check the marking scheme, right? If you check the marking scheme, actually the amount of marks earned for the simple E is less than 1 mark out of 100 sometimes. Maybe 1 mark, maybe 0.5 marks out of 100. I'm talking about out of 100 for the entire paper. But this 1 mark, the 1 mark or 0.5 marks that you earned in the entire physics paper for this kind of questions determine district first and island first rankers. Can you understand here? All students will get A for physics. If they even without answering simple E, all the students get A for physics. But those A passes can be overcome by the students who answered simple E questions also. That kind of questions are very important if you wish to reach to a district rank. Let me read the question once again. If an R value must be larger than 5 ohm is used in the circuit when taking measurements under simple B above, would you expect more accurate or less accurate value for R? Give the reasons for your answer. So simply they have asked whether we should increase, what will happen if we increase R? If the value, not let's say if the R value must larger than 5 ohm is used in this circuit while taking measurements under simple B. Let me show you simple B. What is simple B? Sometimes you may have forgotten. In this experiment, after the apparatus is properly set up, two balance lengths must be taken. What are they? Two balance lengths must be taken. Right. So when we take balance lengths, we have kept R as 5 ohms. So what will happen if we increase the value of R greater than 5 ohm? That's the meaning of the question. So please write a less accurate value will be obtained. A less accurate value will be obtained. Right? What's the question? If an R value much larger than 5 ohm, if R value, that's a typing mistake. That's a typing mistake, not much larger than, much larger than. If the R value much larger than 5 ohm is used in the circuit when taking measurements under symbol B above, would you expect a more accurate answer or less accurate value for simple R? More accurate or less accurate? So we have written less accurate value will be obtained for simple R. A less accurate value for simple R will be obtained. A less accurate value for simple R will be obtained. So what are the changes that we have done? Let me use the circuit to explain this, dear. Right. Listen. Right. They have said if we increase R, this one, what will happen? If we increase this R, dear, the current in this circuit, current does not flow here. No current in this branch and no current in this branch when we take measurements. But there is a current in this part when switch is closed. We obtain L2 balance length by closing the switch S. Then there will be a current in this circuit like this. I have explained it well. If we use a larger value for R, this current will be smaller. This current will be smaller. Once this current is smaller, once this current I is smaller, the balance, this potential difference, let me use a different color and write, the potential difference between this point and this point will be smaller. Will be much equal, sorry, not smaller, will be much equal to capital E. By doing a numerical equation, I can explain it. I think we don't have time now, but I wish to explain it that by doing a numerical example. If R is larger, if this R is larger, current I will be smaller. Once the current I is smaller, the potential difference between this blue color point and this blue color point will be approximately equal to capital E. Will be approximately equal to capital E. Then the biggest upset is this L2 will be larger, and sometimes L2 and L1 will be approximately equal. Will be approximately equal. That's the point. So if that's the answer. There are so many things to explain under this. If you think that you want to understand this further, tell me when we meet next time or when we next week class, then I'll arrange a numerical example and show you the things happen to this L2 balance length when R is increased, right? So please write the reason. Please write the reason. They have asked us a reason. So please write the reason. When capital R is larger, when capital R is larger, the balance lengths L1 and L2 will be approximately equal. Will be approximately equal. When capital R is larger, the balance lengths L1 and L2 will be approximately equal. Then the difference between L1 and L2 will be smaller. Then the difference between L1 and L2 will be smaller. Full stop. Then there will be a larger fractional error. Then there will be a larger fractional error. Then there will be a larger fractional error. Right. So that's the end of the question. Who wants me to repeat the answer? Anybody in the class? Right. So that's the end of the question. Be happy.